Hey there, Ms. Cronin here. We are going to learn about completing the square in this video, as well as how to use completing the square to solve quadratic equations. So the first thing, though, that we're going to look at is what algebra tiles are. So this is an x squared algebra tile, and its dimensions are x by x. And so the area of that would be x squared. So we call this the x squared tile. So the big square is going to be x squared. And then this is called an x tile, and the dimensions of this tile are x by 1 unit here. So from here to here is 1 unit. And then this guy over here is called my unit tile. We're going to use algebra tiles in order to visualize how to complete the square. So the unit tile is 1 by 1, by the way. Okay, so if you have an expression like x squared plus 6x, so what we're really going to do is we're going to like physically make a square with these algebra tiles. So I have my x squared right here, and if I want to represent x squared plus 6x, I have to have 6x tiles. So to make the square, if you split this number 6 in half and put half of the tiles over here, half of the tiles over here, how many unit tiles would you have to add to complete that square down here? So my unit tiles, remember those bars are x by 1. How are you getting the 9?
Just 3 times 3 is 9.
Yes, because once you split that in half, you have, this takes a long time. So what you guys are going to want to do, instead of actually doing the, dragging these around like this, you're going to want to be visualizing what I'm doing and try to replicate it in your brain. I do have algebra tiles, so if you ever want to use them. But yeah, so if you split that, then this is 3 units long here by 3 units in this direction, and so then to complete the square, you'd have to add 3 by 3 or 9 unit tiles. So to complete the square, we add 9, and then I'm going to show you what we can do with that. So we can represent the area of this entire thing in 2 different ways. One way is to just look at all the tiles that we have. We have x squared plus, because this is an x by x tile, so its area is x squared. And then each of these x tiles are x by 1, so that's 6x, because I have 6 of those. And then plus 9. So that's one way to represent the area. Another way to represent the area is, what is this distance here? From here to here is how long? X, and then from here to here is 3 units. So that total distance on that side is x plus 3. You add those lengths together. And it's the same over here. This is x and this is 3. So this total length is x plus 3, or total height. So the area, another way to get area is base times height, and my base and my height are both x plus 3. And so you can actually write this as x plus 3 squared. And you can look, if I FOIL this, I get x squared plus 3x plus inside is 3x, which is going to give me that 6x when I add those together, and then plus 9. So this expression right here is the same as this, which is the same as this, just in different forms. Okay, so I'm going to skip that page. So let's look at the expression x squared plus 10x. We're going to look at how many algebra tiles you need to add to complete the square. And then we're going to write an equivalent expression to the resulting trinomial. So we're going to have that like binomial squared that I had in that last expression. So if I pause this. Okay, so I'm going to drag I'm going to take half of the tiles, I'm going to put them down here. So I'm going to have 5x here, and then I'm going to, sorry, it's hard to get these straight. 1, 2, 3, 4, 5x tiles on this side, and then I'm also going to drag 5x tiles this direction. And you can actually try to arrange these and make a square a different way, and you probably could figure out a different way, but you still have to add the same number of unit tiles to complete the square. Come on. So how many unit tiles would I have to add? Oh, these are falling apart now. All right, so we have 10x and x squared, right? That's what this expression, we have x squared plus 10x. How many unit tiles would you have to add there in order to complete the square? 25, because it would be, so half of the tiles were here, so this leaves us with 5 units in this direction and 5 units in this direction, and so if I complete the square, I would have 5 by 5 unit tiles required, or 25 unit tiles. So think about what we're doing. We're splitting this x, the number of x tiles I have, in half, and then you end up squaring that number because you have 5 on this side, 5 on this side, and so 5 times 5, which is 25. And then to get another way to write the area, this is x and this is 5. So that length is x plus 5, and then the other side is also x plus 5, so the area is x plus 5 squared. All right, so okay, so again, if you think you split that 4x in half, put 2 of them along this side and 2 on this side, how many unit tiles am I going to have to add? Okay, so now we have x squared plus 4x. So I've already dragged these tiles over. I've got, I split the 4x tiles in half, so then I have to add a 2 by 2, or 4 unit tiles to that. So I'm going to add 4 to complete the square. And then, so this represents the area, because we have x squared plus 4x plus 4, that's all the area together. And then another way to write the area is this is x plus 2, which makes this whole length x plus 2. And this is also going to be x plus 2 along this side because it's a square. So another way to write that is x plus 2 times x plus 2, or x plus 2 squared. All right, so I want you guys to think about how to complete the square and then write this binomial here that would end up being squared. Okay, so now I have the x squared plus 8x. I dragged those x tiles over. And then think about, it's very time consuming to drag all those tiles, so what I'm just going to do is just think about it. This is going to be 4 by 4, so I'd have to add 16 unit tiles to this. Okay, so now we have this area can be represented by adding that tiles together, x squared plus 4x and 4x, or 8x, plus the 16. Or another way to represent this area is, how long is this from here to here? 4. Or x plus 4, and that's also x plus 4. So it's going to be x plus 4. Another way to write the area is x plus 4 times x plus 4, because the square has the same length and width. And then you can write that as x plus 4 squared. Now notice, the number of, we split this in half. We divided that 8 by 2, and we put 4 along here and 4 along here, which ends up being the number of unit tiles we have to add is always this number, half of this number, which is 4, and then squared, because we have 4 by 4. So 4 squared is how many we had to add. And also notice that when it factors into x plus that number squared. All right? And so what I want to do right now is I'm going to show you how to do this to solve an equation. So if we have this equation right here, x squared plus 6x plus 4, and I'm trying to figure out where it equals 0, you've learned how to do it by graphing, and you've learned how to do it by factoring. Now we're going to learn how to do it using this new skill, completing the square. So what we're going to do is I just want these two terms, and then I'm going to complete the square on that expression. So what I'm going to do first is I subtract 4 from both sides, which is written over there as well. But I get x squared plus 6x, and I'm going to leave a blank space because I'm going to add something here to complete the square. So think about think about this visually. You have your x squared. How many am I going to put on each side?
3.
Right, so I'm going to take 6, I'm going to divide it by 2, and I'm going to have 3 x tiles. Here, 3 x tiles. Whoa, that's a terrible drawing, but how many units by how many unit tiles do I have to add? 3 by 3, which is 9. So what we do is we take that number that we took half of the x tiles. So we took half of 6, right over here because it's not absolute value, and then we square that number because it's a 3 by 3. So 3 squared is what's going right here. I got to add 3 squared. If I do that to one side of an equation, what do I have to do to the other side? Do the same thing. So I have to add 9 to that side as well. So so we split that number that's in front of the x, which is, we call it b. We divided it by 2 and then we squared it, and that's what we put right here. And so now I have x squared. I'm going to go over here. X squared plus 6x plus 9 equals -4 plus 9 is 5. Now remember what this factored into? It factored into something squared. What was it? This length is x plus 3, and this is also x plus 3. 6. X plus 3 squared equals 5. And then you're going to use the techniques that you were working on previously in part 1 of this lesson. You're going to take the square root of both sides. Yes, exactly. So you're going to go take the square root, and when you do the square root on this side, you got to do plus or minus. So it's the square root of something squared cancels out. It's just x plus 3, and you get equals plus or minus the square root of 5. And then I can't take the square root of 5 and I can't simplify it, but I'm not done yet because what do I have to do to solve for x?
Isolate it.
How? What do I need to do? You're going to subtract 3. And usually, that's supposed to be a 3 there. Usually when you write that, you write the number that's not under a square root in front, -3, and then it's plus or minus the square root of 5. That's 2 answers. One answer. You can write it like this. This is perfectly fine. But you can also split that up because it's -3 plus the square root of 5 for one answer. And the other answer is -3 minus the square root of 5. And in order to calculate this, you grab a calculator to get the decimal equivalent, but it would just be an approximation. This is an exact answer. And so that's how you solve a quadratic by completing the square.